this session, we are going to start with the new module, that is higher order linear differential equation with constant coefficient from engineering mathematics. So let's start the topic first. Okay, so this is the name of our module. Now let's see what is the form of higher order linear differential equation, how we can express it. So suppose an equation of the form d raised to n y upon dx raised to n plus k1 into d raised to n minus 1 y upon dx raised to n minus 1 plus k2 into d raised to n minus 2 into y upon dx raised to n minus 2 and so on plus k n minus 1 dy by dx plus kn into y, which is equal to x. So let's call it equation number 1. So this equation is called higher order. So this is called higher order linear differential equation with constant coefficients. Okay, where x is a function of x or constant. Okay, so here जो x है वो क्या है, function of x है, capital X is the function of x और it is constant, and k1 k2 k3 and so on kn are constants or coefficients here. So since it is a coefficient here, k1 k2 all are coefficients, so these are constant. Okay, so now we can consider here. Okay, so let d by dx is called capital D, d square by dx square is called d square, and so on d raised to n by dx raised to n is called d raised to n. So now I'll replace d by dx, d square by dx square in equation 1. So we'll get here, so by therefore 1 implies, here we can write d raised to n y plus k1 into d raised to n minus 1 y plus k2 into d raised to n minus 2 into y and so on, so up to k n, okay, into y, which is equal to x. Now by taking y common here, so this can be written as d raised to n plus k1 into d raised to n minus 1 plus k2 into d raised to n minus 2 and so on plus kn into y, which is equal to x. So now we can consider here, so let here this d raised to n plus k1 into d raised to n minus 1 plus k2 into d raised to n minus 2 and so on plus kn. Since this is a function of x, so a function of d, so we can call it as function of d here. So therefore, by replacing this equation here, this equation by f of d, so therefore we'll get f of d into y, which is equal to x. So this is called higher order linear differential equation with constant coefficients. So this is the higher order linear differential equation with constant coefficients. Let's see the general solution of f of d into y is equal to x, or complete solution. So the solution of higher order linear differential equation with constant coefficient f of d into x is equal to f of d into y, f of d into y is equal to x is given by y is equal to cf plus pi, where cf is complementary function plus pi means particular integral. So particular integral. So it means अगर हमें किसी भी डिफरेंशियल इक्वेशन, हायर ऑर्डर लीनियर डिफरेंशियल इक्वेशन का अगर सॉल्यूशन फाइंड करना है, इट मींस वी हैव टू फाइंड कॉम्प्लीमेंट्री फंक्शन प्लस पर्टिकुलर इंटीग्रल. Now let's see how we can find the complementary function or particular integral of any higher order linear differential equation with constant coefficients. So if suppose here we have, so now first we'll discuss about the complementary function. So complementary function. Okay, so the complementary function cf of f of d into y is equal to x is obtained by solving its equation, that is auxiliary equation. So the complementary function, the complementary function of f of d into y is equal to x is obtained by solving f of d is equal to 0 and it is denoted by yc. So complementary function of any higher order linear differential equation can be expressed as yc. Okay, it is denoted by yc. Now there are some rules to find the complementary function. Okay, so now rules for finding CF. Now let f of d into y is equal to x be any higher order linear differential equation with constant coefficients then the f of d is equal to 0 is called auxiliary equation of f of d into y is equal to x. Okay, so now to obtain or to find complementary function we have to solve auxiliary equation. Now as we know, we have learned in smaller standard that if suppose we have any polynomials with degree n, it means it will have maximum n roots. Okay, मतलब अगर कोई इक्वेशन है अगर वो उसका डिग्री और पावर n है, so it means that equation will have n number of roots. So the complementary function is dependent upon the nature of roots. So I have written the rules to find or the equations to find the complementary function as first I have written auxiliary equation, roots of auxiliary equation on the left hand side and the complementary function on the right hand side. So first one, if we have the roots m1, m2, m3, m4 up to mn and all are real and distinct, then its equation or complementary function is given by yc is equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x dot cn e raised to mnx. ओके, मतलब अगर हमारे पास 10 रूट्स है और 10 रूट्स सारे रूट्स क्या हैं, डिस्टिंक्ट, डिफरेंट, तो हम क्या करेंगे, इसका कॉम्प्लीमेंट्री फंक्शन लिखेंगे c1 प्लस e रेज टू फर्स्ट रूट into x plus c2 e raised to second root into x plus c3 into e raised to third root into x and so on. टोटल ऐसे 10 टर्म्स बनेंगे. नाउ सेकेंड रूल, अगर सपोज हमारे पास दो रूट्स रिपीटेड है, सपोज वी हैव m1 रिपीटेड सेम और m3 m4 m5 m6 एंड mn, ये सारे रूट डिस्टिंक्ट है, डिफरेंट. ओके, देन सिंस हियर टू रूट्स आर रिपीटेड, सो वी विल राइट c1 plus c2x into e raised to m1x. ओके, वो दो रूट्स के लिए. बाकी जितने रूट्स बच गए m3 m4 m5 m6 up to mn, all are distinct, so for them we can write c3 e raised to m3x plus c4 e raised to m4x and so on cn e raised to mnx. ओके, अच्छा, सिमिलरली अगर हमारे पास तीन रूट्स है जो रिपीटेड है, ओके, फॉर एग्जांपल वी हैव थर्ड रूल दैट m1 m1 m1, तीनों रूट्स सेम है. नाउ फोर्थ रूट m4, फिफ्थ रूट m5 एंड सो ऑन ऐसे चेंज हो रहे हैं. सो तीन रूट्स m1 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 सेम है, बाकी सारे डिस्टिंक्ट है. सो स्टार्टिंग की जो थ्री रूट्स सेम है उनके लिए लिखेंगे हम c1 प्लस c2x प्लस c3 e रेज टू x स्क्वायर, सॉरी c3 x स्क्वायर into e रेज टू m1x. ओके, so I am repeating again, तीन रूट्स है m1 m1 m1, तो फर्स्ट वन हम फर्स्ट रूट के लिए लिखेंगे c1, सेकेंड रूट के लिए c2x और थर्ड रूट के लिए c3 स्क्वायर. ओके, ब्रैकेट क्लोज. e रेज टू m1x प्लस, अब डिस्टिंक्ट रूट्स जितने m4 m5 m6 एंड सो ऑन, उसके लिए लिखेंगे हम c4 e रेज टू m4x प्लस c5 e रेज टू m5x एंड सो ऑन. ओके, अच्छा, अब अगर सपोज किसी भी डिफरेंशियल इक्वेशन के रूट्स जरूरी नहीं है कि वो रियल नंबर हो, दे मे बी कॉम्प्लेक्स. तो कॉम्प्लेक्स होंगे तो क्या? सो नाउ हियर फोर्थ रूल, if we have a two roots complex, so m1 is given as alpha plus I beta and m2 is given as alpha minus I beta. I means iota, that is under root of minus 1 means complex roots, and remaining m3 m4 m5 up to mn all are real and distinct. So for them, for m1 m2 as they are complex, and here the first term without I जो होगा that is alpha और with I जो होगा that is called beta. So इसका complementary function होगा e raised to alpha x in bracket c1 cos beta x plus c2 sin beta x bracket close plus, अब जो बच गया कांस्टेंट जो रियल रूट्स थे m4 और m3 m4 m5 एंड सो ऑन, उनके लिए हम लिखेंगे c3 e raised to m3x plus c4 e raised to m4x एंड सो ऑन. ओके, नाउ पॉसिबिलिटी ये भी है कि अगर हमारे पास सपोज रूट्स रिपीटेड हो, ओके, कॉम्प्लेक्स में बट रिपीटेड रूट्स. सो नाउ फिफ्थ वन, हियर वी हैव m1 and m3 same complex root means repeated, and m2 m4 are complex root repeated alpha minus I beta. Okay, so now for them and remaining are m5 m6 जितने भी हैं सारे real distinct root हैं. So for them we can write e raised to alpha x in bracket c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x, and जो रूट्स हैं रियल रूट्स, ओके, डिस्टिंक्ट m5 m6 m7 इनके लिए सेम c5 e raised to m5x plus c6 e raised to m6x and so on. Okay, so these five are the rules. You can consider rules, formula. By using, we can find the complementary function. So just remember all these formulas we are going to solve, or we are going to find complementary function by using these formulas. So let's see some problem based on complementary function. So first one, find complementary function of d cube plus 4d square plus d minus 6 into y is equal to 0. So this is the question. Okay, so solution. So first the auxiliary equation. So auxiliary equation is d cube plus 4d square plus d minus 6 is equal to 0. So this is our auxiliary equation. Now by solving this auxiliary equation, we will have three roots. They may be repeated or they may be distinct. Okay, so therefore by solving this, the roots of auxiliary equation are, so here we have 1 minus 2 minus 3, three roots, and all are distinct. Okay, so all three roots are real and distinct. अगर ये तीनों रूट्स रियल एंड डिस्टिंक्ट हैं तो कौन सा रूट फॉलो करेंगे हम? फर्स्ट रूल. ओके, सो देयरफॉर द कॉम्प्लीमेंट्री फंक्शन इज yc is equal to c1 e raised to m1, that is फर्स्ट रूट. यहाँ पे हमारा फर्स्ट रूट है 1, so 1 into x plus c2 e raised to minus 2x plus c3 e raised to minus 3x. So ये हो गया हमारा कॉम्प्लीमेंट्री फंक्शन. Now similarly we can have the another one. So if suppose I have here another question, so problem number 2. Okay, so find complementary function of d cube plus d square into y is equal to 0. Okay, so solution: let auxiliary equation is d cube plus d square which is equal to 0. Okay, this is our auxiliary equation. अब इसे सॉल्व कैसे करेंगे? Now I can take d square common, so therefore we have d square in bracket d plus 1 which is equal to 0. Now it means d square into d plus 1 equal to 0. It means d square it will be 0 or d plus 1 will be 0. So therefore d is equal to 0, 0, minus 1. Now here we have three roots 0, 0, minus 1. Okay, तो ये तीन रूट्स में से तो जो दो रूट्स हैं 0, 0 वो रिपीटेड हैं बट रियल है. ओके, सो देयरफॉर रूट्स of auxiliary equation are 0, 0, minus 1. So अब ये repeated roots हैं, so we can write, so therefore complementary function is yc is equal to c1 plus c2x in bracket now e raised to 0x plus c3 e raised to minus 1 into x. Now e raised to 0x means e raised to 0 and e raised to 0 की वैल्यू कितनी होगी 1. So we can write here yc is equal to c1 plus c2x plus c3 e raised to minus x. तो ये हो गया हमारा कॉम्प्लीमेंट्री फंक्शन.